Welcome aboard the A-Star ship. My name is Kale, and we are working on some advanced artificial intelligence using a monoid structure in order to compress the AI abstract operation space so that we can, one, undo what we're doing with the snack machine using the monoid identity function. You know, the inverse function. We're doing basically, essentially, it's just a stack machine and it's just contiguous. And then we pop it off and then it's back to where it was at. And, but you can use this monoid group theory in order to mathematically formalize, make sure that the AI, whatever symbolic operations it just came up with. When I say symbolic operations, I mean post-transformer symbolic operations where the AI has developed symbols. And as long as these symbols are in a monoid format, then we can, it's like we can manipulate them like it's like the base 10 number system or base 2 or whatever. So that's a little bit of a tangent. We're doing low-level Unicode debugging with Visual Studio and Copilot, and then we'll get over to the advanced artificial intelligence. But first, we have to, like, what the hell does this thing even do? No, I'm not going to get sidetracked. We've got a whole bunch of stuff. Ooh. So here are the functions that it said we need to implement. And this is for the release for comment, internet data specification or protocol specification with the data specification in it. I get to submit to the Internet Task Force so we could be an official protocol. But we're going to get sidetracked here. I don't want to really do that. That's not what you clicked here on the video for. So we're looking at the timestamp. What the hell is it doing? It is, I fixed all the Unicode API errors where it wasn't printing Unicode. I wasn't testing Unicode. I just speak English, you know. So I made it kind of work, fudged it for Unicode, but it didn't do UTF-8 correctly. So now it's doing the UTF-8 correctly, and I can also do the ASCII because it's difficult when you're doing I'm using a C++ operator overloader set. And so it's a little bit difficult when you're working with templates and you have a UTF-8 string and a an ASCII string, because both of them use a char star string pointer. Both of them have an 8-bit character, but they're not used the same. Like the UTF-8, you got to like convert that into a UTF-32. So I came up with a nice elegant solution where we use this char T thing. So I just this fixed it right up. You know, I was pretty happy. We just have the character string. That's the CHS. IS is integer signed. IU integer unsigned. And then CHT is the character type. So this is going to be either a 8-bit Unicode character or 8-bit ASCII character or a 32-bit Unicode character. So then we have this problem where I'm now working 2 issues at the same time because it just became OpenClaw happened. So now we're making a Chinese room OpenClaw clone. And then we got the 64-bit UUID library. where was this? Here is the. Let's see. That's no, I don't. Anything to save that. Script spec. What is this? Grab spec. I don't want to do anything to mess with that. And this is. What the hell is that? I have no idea why that's up there. Don't say. All right. So, where are we at? We have that monoid Chinese room. This is going to be very interesting. Here is the LLM's version of what it thinks the crabs how the monoid should be. It did identify some errors. We're like, no, you don't have the inverse function correct. So we're gonna see what's happening here. I don't want to get sidetracked. I just thought that that was pretty cool. What did I just do? No, what that was. So we got to look at the data spec before I get sidetracked again. So we got the clock. So what do we got? We got the 64-bit sub-second ID and ID bit pattern. So we got the hot UUID, and this is going to have it's always less than 192. So the hot one, if you ask me, maybe I don't need that anymore. See, because this, I have an 8-bit sub-second ticker, and then I took off, what did I took off? I took off something. Always less than 192. If it's over 192, then, so we want to convert from our hot bit pattern to our cold bit pattern. And our cold bit pattern has a 34-bit unsigned seconds timestamp with a 29-bit sub-second ticker. What that means is that all you get is 2 to the 29th, which is half a billion different UUIDs per second that you can generate in your distributed system as a whole. So, and then we have the 128-bit this is supposed to say sub-second ID bit pattern. Does it say? So the time ticker, that one's a traditional x86 timestamp with a sub-second, sorry, a 32-bit unsigned, sorry, 32-bit signed timestamp and then a 32-bit unsigned sub-second ticker. And what that is going to do is, stream, that is going to, sorry, x86 does not have a seconds or a sub-second timestamp. Instead, you have to use a thread on the x86 CPU in order to do your clocks. And the x86 has specialized hardware that detects if you're doing a spin ticker, and it actually works like a normal ticker. It's kind of weird. It's like really old. It's hacked together, but hey, it works. So, what are you going to do? Ain't broke, don't fix it, right? So what are we going to do? Now we have okay. Short timestamp. See, if I do 4 years, then I don't have to do this funny hot bit pattern. So what does that mean? So this, where are these bits at? I don't really want this thing to be like this. So, I mean, I would eagerly, if we could convert the timestamp into, here, let me just restart this from scratch. The SSD type is a 64-bit sub-second ID with 3-bit patterns: a hot UUID bit pattern, cold UUID bit pattern, and evergreen UUID bit pattern. The cold and evergreen UUID bit patterns are designed to have sharp timestamp epoch of, let's just start changing it, 4 years. That is easy to look up the cold UUID bit pattern using a binary search. The all SSDs are unsigned. Use unsigned seconds and unsigned ticks because they're wrap around after each epoch. I don't think that's not really. I don't think it's really true. The number of sub-second ticks has been capped at. Just delete that. Hot UUIDs are designed to be used by distributed hot-to-archive databases. Servers may use one randomly generated number for their source ID or a pool of assigned random numbers or whatever the stakeholders want. A 34-bit sub-second timer was chosen for the cold UUID bit pattern because of its 544.4 year epoch, making sure everyone around today is long gone and in the simulation. The cold UUID's 29-bit sub-second ticker. Didn't I? Isn't it 34? Wait, 20. 34-bit sub-second ticker allows for over 5 million UUIDs generated per second for the entire distributed system. 5 million? 500 million. The whole distributed data system, which is enough for the vast majority of use cases. That's kind of a long sentence. While enough for the vast majority of use cases, no UUID format is a silver bullet. We work for most use cases. We mitigate this using evergreen ID, which require generating a random number at runtime, rate limiting the UUIDs per second. All hot UUIDs must be moved to cold database within 4 years. or be converted to evergreen UUID. When hot UUIDs are converted to cold UUIDs, the index must be sorted to allow for binary search lookup based on the hot UUID. All right. So now of which we only use 4. Okay, so now seconds timestamp is always under, it's always 1. And the seconds is always less than 4 times 365.25 times 60 times, times 24 times 60 times 60. The number of seconds in 4 years. And then we're just going to have to put that in, whatever that is, 4 times 365.25 times 24 times 60. Huh? Times 60. 365.24 times the 60 times 60. All right. Okay. Evergreen UUID bit pattern. All right. So evergreen bit patterns are created the MSB of the, wait, how do I phrase that? Always less than less than what? Is always greater than or equal to bits. Okay, so now we need to calculate how many bits we have left. So it's 2 to the 27 minus 126,230,400. All right. Leaving. Wait, I got to convert this to the exact number of bits. So how do we do that? Okay. All right, convert this to the number of bits. So we want a log base 2 calculator. I'm going to look that up real quick. What is the log base 2? We have 22 bits. less than, which is 22 bits. And less than, and then we do 2 to the 22. What? So we still have a bunch left over. Wow. So I still can hack something else. Okay, so then I now have another giant chunk of bits that I have to work with. So let's look at this logistically. 22 plus huh. Kind of hurts my head a little bit. I'm going to do a little bit of Unicode programming and I'm going to think about that. So what do we got going on here? Let's look at the output for the debugger. We have because I don't really need that particular thing to. When are we looking for T clock print? Probably should be in. Fix that real quick here. This thing wants to glitch out anytime I move a window to another desktop. Gotta fix the 4K glitching. I'm using kind of frustrating that Windows does this. I'm just using a 4K monitor split up into 4 1080p monitors, and then I'm live streaming now in 720p because I realize that YouTube is penalizing people who don't have like new channels who don't have a lot of viewers if they're using too much, if they're live streaming in 1080p because they're not processing your videos for a day. If you use the 720p, it processes it right away. And there's not much of a difference, really, when you're doing live coding, if you're doing it right, between the two. Okay, so the evergreen, bit pattern. So this thing is, see, I like this better because we're actually, instead of taking some bits from here, which I'm actually taking like, I think like half a bit or something from there. Uh, Instead, I'm taking half a bit from the timestamp. So I'm not 100% sure if that is exactly what I want to do, because it's like, what does an evergreen bit pattern actually do? So the evergreen bit pattern, second ticker. Okay. So if I have, what do I have? Oops. Let's real quick before I forget what I'm doing. Mine is 4194 304 41. 9. All right. So here is one option is that I could like have instead of like a sub-second ticker, I could do like a day ticker to where I mean at least like with if it's just one day, then it's not going to have a giant number of well, no, it could totally have a giant number of database entries, but I'm not 100% sure. Actually, now looking at this, if this would work. So, what's happening? Okay, the extra bits from the evergreen UUID bit format have values. And then let's look up again. What is that? Which is 21 bits. Which is 21 bits. Now we're going to subtract 2 to the 21. And then that's going to leave. So that's going to leave. Which is, now we're going to take that, which is now 20 bits. So it's like, I don't know what to do here with this because there's quite a bit of different buckets that you could have with this. So let's make a table of this. So, um, what is it? 20 bits. 20 bits leaving minus 2 to the 20th. Which is 19 bits. I mean, I can see the pattern here. It seems like why is there I feel like maybe I'm cheating here. Why are there so many bit values? Am I just like in my mind making up like that this is more useful than what it would be? So, I mean, I like this idea of how it's like what I'm doing, but I feel like maybe I'm either cheating or like this is just going to be fruitless because of, like I'm not thinking. So what is 96, which is what? 19 bits. It's starting to get big and I don't really want to. So here, let's get a proper table going on over here. And then what am I trying to do? I just want to like kind of think about this for a second, and then I got to get back to the Unicode because that's what I said I was doing. So what did it did this yield any fruit? Clock. Oh, there's the rest of it. Okay, so these were bugs that it fixed, which I was pretty happy with. The thing's confused about the 28-bit timestamp. Common 64-bit timestamp patterns. Yeah, this is mine is way better than theirs, dude. Theirs sucks, dude. This sub-second ID bit format is actually really good. Here's the Mongo ID, or sorry, MongoDB object ID, specific ideas for the overflow boundary. This could be archive pending, not yet moved, flagged for. I don't think that this makes sense. Like archive pending, I don't think it makes sense at all. Because I think you need to move the data from hot to archive after like 3.5 years. I mean, what do you need 6 months to move your stuff to another database? I mean, maybe. Kind of sounds like a little bit of extreme of a time window, so I'm going to stick with that. So, tombstones, deleted record markers, distributed for GC. I mean, a tombstone, maybe. I don't think so. I don't think a tombstone makes sense either. Unless it's like at the very end of my unrolling this bit pattern, like I was just doing. So the cleanest single purpose for the use of this sequence overflow pattern is capacity max, overflow range. Practical notes. None of these really make too much sense. So, all right, can we ask it? Let's see if it can figure this out. Um, let's create a new session and can it yeah, how long is it going to take to respond to that? That's what I'm wondering. So let's look at where the line is at. 74 in I mean the unit test. Line 74. Right here. So I scanned the time. So I clock TMS. T clock timestamp. Now we take the year and we minus the epoch. Hold on, this doesn't make sense. So let's take the year. The epoch is 4 years. Okay. Okay, so I mean this works. This makes sense for um like a Unix timestamp when like we're in the correct. So the epoch, I guess I'm gonna have to submit a different epoch for the. So the epoch is like 1970 for a Unix timestamp, right? So, but okay, I'm trying to subtract for. I'm being an idiot. So we got the clock epoch, and then for a normal epoch, we're just gonna use this clock epoch year, and then that's the Unix timestamp. All right. So where am I storing this? Oh, right. So let's do if scene is less than crabs. Right now I'll just do that. That's just fine. Else. Now what I'm gonna have to do is end if. Now I'm gonna have to get the Chinese room from static memory here. So if this is equal to clock. Now we do in here. I think we just include the crabs.h in here, right? So in crabs.h, let's go look over here. Crabs is going to have our expression scanner for the remote procedure calls or whatever other compiler you're trying to build. And then what? Uh, oh, I cannot wait till this thing. I'm just finishes. I just am so happy I have an AI to assist me with my open source projects because I just work for free. I ain't getting no money out of this shit. I'm just like eagerly awaiting. It's like so. What do we have here? So the crabs machine. This is like the hottest that it's getting. So do I need two different timestamps? I probably don't want to do two different timestamps. Epochs. So I know I need to stick it in here. And it needs to be. So we need like a TMC here. That's time. That's a 32-bit timestamp. This is all right. So let's think about this for a second. The Unix timestamp is. Do I need a TMC for that? Or do I just check it in the years format? Because it seems to me like the my brain is kind of breaking when I think about a 4-year timestamp. Like I don't really have to think about a Unix timestamp. I've been doing it for so long. But um, now this other bit pattern now sneaking here is getting to be a little bit more unbearable. Now let's see if we can get something on this though. Um, 21. Wait, and then what is it? The spread is what, 2 to the 21? Do I really need it? I don't need to write the spread. It's in the bits. That's a trivial calculation. So I have to do this continually down the line um, to minus 2 to the 19th. Now we're going to minus 2 to the 18th. What the hell did I just do? Damn it. It's 2 to the 18th. No. Huh? Why is this 16? Huh? I thought I would have just gone down 16. So this one was minus with a 19.3, which is... It's not. This one jumped. This one skipped one. I wasn't expecting that. That was actually kind of interesting. I wonder if there's anything to that. And it's minus 2 to the 16th on this one. That's actually kind of interesting, the way that this math is working out. And 15. I wonder how many more times it skips. Two to the 15. $14. Boy, it's quite a bit. $13. It's going to skip on the next one. How do I know that? It's got it's almost near the log. It's like almost to the base power. So we'll see if it skips. Nope. This is minus 2 to the 13th, minus 2 to the 13th. Huh? What? 2 to the 13th? Oh, whoa. Really? I was not expecting that. I was not expecting that. And then it unravels down to this is 7 bits. That's such a strange bit pattern. How did it go? And then it's a base 2. So then it doesn't have the bit pattern anymore beyond that. That is so strange. I was not expecting that. What I was expecting when I unrolled this bit pattern was to see it go 21, 20, 19, 18, 17, 16. But I think it eventually dropped to a power of 2 and then it was done. Yeah, it started approaching. So it's like, what happened here? Did I even do this right? Am I like an idiot? So I can take 3793024. 3793024 minus 2 to the 21th. Minus 2 to the 20th. Minus 2 to the 19th. Minus 2 to the 18th. What did I do? Yeah, this is wrong. I have 2 of these rows. This isn't right. And then it's minus 18 minus 2 to the 15th. And then that's what? No, it's 2 to the 16th? Wait. Huh? Wait. 123,008 minus 2 to the 16? 123,008 minus 2 to the 17. No, it's the 16. Okay, 123,008 minus 2 to the. Did I just say 17? 16. Minus 2 to the 14. Hold on, let me. 3793. 024 minus 2 to the 21st minus 2 to the 20th minus 2 to the 19th minus 2 to the 16th minus 2 to the 15th? Yeah. Minus 2 to the 14th? Yeah, we got a 14 minus 2 to the 13th, and then it goes down to the A. What? I'm off by 1. Son of a bee. Okay, so let's test this out because I'm having a lot of problems. Okay, so it's first off 2 to the 27 minus 365.25 times 24 times 60 times 60. And then that is this. That's the number I went up with. So that's, wait, 365.25 times 24 times 60 times 60 times 4. Right, that was the one that I missed. So it's 2 to the 27 minus that. And then we end up with this number. Okay. And so then that first one is reserved. Okay, so the extra bits, leaving that is, okay, so 22 which is what, 22 bits. Twenty-two bits for the evergreen UUID left over with minus 2 to the 22nd. Okay. That's a solid number. And so if it's in between, all right, so we've gone past the 4-year timestamp. And then it's over that. So now we have a value that's in the seconds timestamp that is encoded. And so we need to then convert that encoded value back into the in relation to 0 so that we can use it for our indexes, because it's not useful when it's like up in the upper register. So we subtract the number of seconds in 4 years with my hand wavy. You like that? You like that? You like that? All right. Then we're going to do the 21. So then if it's in one of these ranges, I'm going to do something else for it. So we have, and this is, mind you, this is bits left over in the timestamp. And then there's the sub-second ticker. And then there's the source ID, which is 28 bits. But with an evergreen ID, we don't have a source ID. And so this is, a limitation of the system we're designing. We got a very limited number of bits, and we're utilizing them to 100% capacity. And so we need to so if it's in between, let's say it's in between, going back to the 0 origin, if it's in between 0 and this number, then it is the evergreen ID. If it's between this number plus this number, then it's some other type of ID. And then it's going to have 20 bits in it. And it seems like I'm cheating, like I shouldn't be able to split it up this way, but I'm almost 100% positive that I can. Not 100% positive that I'm being a bozo idiot right now, but I'm 100% positive that we can do something with this bit pattern because I've seen a lot of bit patterns. But let me double check to make sure that I have the correct numbers. We're going to do 3793024. We're going to subtract 2 to the 21 just to make sure. Is it negative? Or 2 to the 22. Yeah, I wouldn't be able to actually. So 3793024 minus 2 to the 22. And then that's going to be a negative number. So we know it's 21. So now we do 3793 minus, 3793024 minus 2 to the 21. Now we're left over with this. Now we're going to do this number minus 2 to the 21 just to make sure, right? But then we do 2 to the 20th because now we verified. So now that I have this number, now I'm going to do this minus 2 to the 20th just to verify that I'm not an idiot. No, I'm not. So we can do 2 to the, this minus 2 to the 19th. Okay, and now we are at 2 to the 18th. So again, we're going to take this minus 2 to the 19th just to make sure I'm not an idiot. No. So this minus 2 to the 18th is going to leave over. Oh, so it can't be. It's 17. Whoa, it's 16? How did I do that? 3793 minus. So this minus 2 to the 16th is 1. That's negative? Huh. Okay. So this one's 16 minus 2 to the 16th minus 2 to the 15th? Two to the 15th. That was not right. Yeah, this couldn't be that. It would have to be 14th because 2 to the 16th is 64K. 2 to the 15th is 64K. So now it is 2 to the 14th. And that's this. And then that's minus 2 to the, what, 13th? And that's 13. Gotcha. All right. That's it. This is our bit pattern. So this will allow us to break up our IDs into plus the evergreen bit pattern. We'll have, maybe I'll just add this. Evergreen. And then just for good measure, we're going to add this back into the thing. Where's that thing? There. Wait. So now what we're going to do is we're going to super four-year UUID. Okay, so super four-year UUID means that the timestamp is over this. We subtracted this, which is this. Is it 22 bits? Okay, so now we can break up our bits. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9 different groups. All right. All right. Total bits is 22 plus sorry, that's 36, right? I don't have to do that. That'd be ridiculous. So 36 plus 22 is 48. 47. And then 6 bits. Fine. Now we're doing 42. Why is there a 16? Oh, man. Why is there two 16s here? This has to be 15. I'm really upset with myself that this should not happen. Okay. It was just a typo. 1942, 41, 40, 36 with 14. Wait. Oh, idiot. And then, because it's 36 plus 13, 46, 40. And then 36 plus 7 is 36 plus 7, 43, right? All right, because obviously you cannot trust me right now. I'm going to just verify that I am not a bozo. 28 plus 8 plus 7 is 43. Okay. Minus 7 is 13. 49. So 13, 14, 15, 16. We're skipping 17, 18. All right. All right. Well, I've been on this live stream for an hour. I gotta go eat some dinner here in a little bit. So I want to get the the thing figured out. So the Crabs machine is going to be aligned to a cache line. This is going to be the hottest data. So like pretty much some of the hottest data that we're going to have here is right here. So I don't know why we have pointers here operating. Okay, yeah, so there's a bunch of contiguous slots, and then I'm going to select one of the slots. Slot for unpacking the B sequence too. Okay, so we got one super hot slot here. And slots can go in and out of the system. They're like a ring buffer, essentially. So let us say the standard crabs. Standard crabs. Oh, I'm sorry. It's the standard crabs, the STD crabs, baby. I just love this API. Giving everybody STD crabs, baby. Yes. And what is happening? So here we're gonna don't want an inline. Do we? So static or static. Hold on. Do I have to pre-allocate the entire Chinese room ahead of time? Yes. How do I do that again? That's kind of embarrassing. So it's my config, right? It better be, or else I'm gonna be pissed. Config footer, these are my default ones. Config default. What is it? Shift. What size of the integer? Minus 2. I get a 32K. What is it gonna be? What, 16? Just default to a 32K. 28. We'll just say 2 to the 24th, 2 to the 28th. I mean, that seems to be okay to me. I don't think too many people are gonna argue with um 2 to the 28th is like 250 megabytes. Yeah, that's a lot. How about the 2 to the 24th? That's a 16 megabyte. How about we just do 2 to the 20th? 1 megabyte. All right. 2 to the 20th. Crabs. Um, room button. So now we're gonna go to the back to the crabs machine over here. And crabs machine equals, wait, hold on, no, static is wool, baby. What do I do now? I need to like hash align it. Where's the binary? Shoot, I forgot how to use my own algorithms, dude. T is aligned. Align up. A CPU ALU mask. A CPU mask. What is this? Okay, so this is I'm gonna call it a CPU word because that just did not. It's not really one. Um, we just want a line up. Where the hell did it go? God damn it. I didn't close that window. Okay. You know, I don't really want to use this. This is only supposed to be here for temporary purposes, and I'm supposed to convert it over to an enum. So let's now go over to the footer. Let's go convert this over to the permanent thing in the footer. Rams max. Yeah, man. Okay. Too happy with that. So now we want to, on here, go down and undo that. Okay, so now what do I gotta do? I gotta, no, 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 IUA. Now we want to do, hold on. line up. Room to a cache line. This cache line size. That's how I use my thing, right? Just go look in binary. See if this actually worked. A CPU word align mask. Okay. And then the cache line size is, damn it. I hate how the thing keeps, I just want to manually open up the windows, and then I really don't like how it keeps automatically closing the windows on me. Cache line size is supposed to be 64, so it says 64, right? Okay, that's all I need. Right there, cache line size, -1. Wait, don't we need to do a putter? Where's the putter? Align, putter up, okay. So putter up, align that, and then we're good to go. Reinterpret cast. Not really doing a whole lot other than that. We're just aligning. We're going to the base of this. We're word aligning up to a 64 byte boundary. Oh, wait, hold on. 64 bytes. Cache line size 63. Yeah, that's what I want. Okay. So now that we have that here, so I'm not passing in the epoch print. So I'm not passing in the epoch. But, I can just actually just keep this a Unix timestamp. Don't I have? Oh, there's no epoch. All right. Well, I'm running out of time. I got to go do my dinner. I wanted to get farther, but I'm going to come back and I'm going to get more on top of the ASCII Unicode, because I can't really fix this Unicode API until I've determined exactly what the hell a timestamp is. So I do feel like I had success. I wish that I had written the correct thing on the video timestamp, but I am working on the Unicode API. I'm just going to print the timestamps. It just has an extra step in it. So thanks for tuning in. I don't think anybody's watching, but have a good night.